Howdy. In this video, I'm going to show a correlation example. I have a sample of 17 infants with their gestational age and birth weight. So we are doing a correlation analysis, and the formulas are here. I'm going to do two ways, or solve this problem two different ways. One, using completely Excel built-in functions, correlation function, and the other one is basically replicating these calculations through some built-in function and specified calculations. Right. So first I need to do I need A bar and B bar. Those are the averages. So I'm gonna calculate those averages. And average is equal to, there's an average function, and I am going to get the average of these 17 cells. And I'm gonna just copy this value here, right? And then I also need the standard deviation. Remember, we have only the samples, not the actual population. Usually I would say SA, but the book shows the sigma A, so I'm just going to replicate that one. In statistics, sigma stands for the population standard deviation versus S stands for the sample deviation. Anyway, so I'm going to calculate the standard deviation of sample, and this is the formula. But again, I'm going to use the built-in Excel function to calculate that value. Right. So standard deviation of a sample is stdev s, estimates the standard deviation based on the sample, right? So I'm going to use that function, and again, this is the set of values. So that means 3.15 standard deviation and about 700 grams of weight, right? So once I have these four values, I'm gonna go calculate this one. I could do this one as well, but in that case I have to create two columns, so I'm just trying to avoid that one. So I need AI times BI values, and I'm gonna just say AI BI, right? And that is equal to, as the name suggests, multiplication of these values, and then copy for all of them. Then I need to sum them. So here's my sum, and I'm going to actually do it here. Sum all these values. Right. So now I have the sum and the rest of the values. So I need to calculate this up over value and then divide by this n-1 sigma A sigma B. All right. So let me say RAB here. All right. If I can just say R A comma B, and then make these as subscript. Right. So here's the formula. Let's start. It is equal to, and I'm going to open parentheses here, A times BI, AI BI, that is this, minus N value, and I know N value is 17, right? Or actually, times A bar and B bar, those are the averages. Okay, so that is the top, and then I'm gonna divide that one by n-1, that is 16, times standard deviation of A and standard deviation of B, then close this parentheses, right? So that is 0.817519. That's a strong correlation basically between A and B. Right, so it was really straightforward and easy. Of course, I used the standard deviation and average function built in, so that made my life a little bit easier. Now, I could also directly calculate this RAB using the correlation function. Let's use that one as well. So returns the correlation coefficient between two data sets, right? Here's my first data array, And here's the second one. So I'm saying basically gestational age and birth weight, all the values selected. Close this one. And that is exactly as the other one if I want to show it to you guys, right? So this is much better. Again, first I showed you how to do it step by step and then use the correlation function. If such an assignment is in the exam, you may use directly the correlation function and be done with it.